What are the key differences between DHCP and DHCPv6? Imagine you're trying to connect your device to the internet, and it needs an IP address to communicate. How does it get that address? That's where DHCP and DHCPv6 come into play. These are protocols that help assign IP addresses automatically, but they work differently depending on whether you're using IPv4 or IPv6. Let's explore how they compare and what makes each one unique. DHCP stands for Dynamic Host Configuration Protocol. It was created for IPv4 networks, which use 32-bit addresses. These addresses are like phone numbers for devices on the internet. DHCP makes it easy for devices to get an IP address without manual setup. DHCPv6, on the other hand, is designed specifically for IPv6 networks, which use 128-bit addresses. These addresses are much longer and more complex, so DHCPv6 had to be built with new features. In IPv4 networks, DHCP is usually enabled on specific network interfaces. That means network administrators turn it on for each device or subnet. For IPv6, DHCPv6 can be enabled on a per-physical interface, but often routers send out advertisements that tell devices how to configure themselves. This means IPv6 devices can often set up their addresses automatically without DHCPv6, thanks to a feature called stateless address auto-configuration. DHCPv6 can also work alongside this, providing extra details like DNS servers. The way devices get their addresses also differs. DHCP4 uses a process called DORA, which stands for Discover, Offer, Request, and Acknowledge. Devices broadcast a request to find a DHCP server, and then the server offers an address. The device requests it, and the server confirms. This process involves broadcasting messages to all devices on the network. DHCPv6 uses a different method called SAR, which stands for Solicit, Advertise, Request, and Reply. Instead of broadcasting, devices send multicast messages to find DHCPv6 servers, reducing unnecessary network traffic. Another key difference is how network information like the default gateway and subnet mask is provided. In IPv4, DHCP servers send this info directly to devices. In IPv6, devices learn about the network's prefix length and default gateway from router advertisements sent by routers. DHCPv6 mainly supplies other details such as DNS servers, not the address itself. The ports used for communication are different too. DHCP4 uses UDP, port 67 and 68. DHCPv6 uses UDP, ports 546 for clients and 547 for servers and relay agents. This helps keep the two protocols separate and organized. Support for hostnames is another distinction. DHCP4 can assign hostnames to devices, making it easier to identify them. DHCPv6 does not include a hostname option, focusing instead on addresses and network parameters. IPv6 networks often use stateless address auto-configuration, which allows devices to generate their own addresses without DHCPv6. When DHCPv6 is used, it can operate in two modes: stateful, where the server assigns addresses and other info, or stateless, which only provides additional configuration like DNS servers. This flexibility helps networks adapt to different needs. Relay agents are used to forward requests across subnets. In IPv4, this is done with the IP helper address command. DHCPv6 uses multicast relay agents with special multicast addresses, requiring different configuration. Understanding these differences helps network engineers manage both IPv4 and IPv6 networks effectively. As IPv6 adoption grows, knowing how DHCP and DHCPv6 work ensures devices get the right addresses and configurations smoothly, keeping the internet running seamlessly.